Okay, so today we're going to be solving trig equations. So we have to use what we learned yesterday about inverses to be able to use these today. Okay, so the first thing that we want to do is verify that the x values are solutions to this equation. So verify means we're just checking to see if it works or not. Okay, so here is your equation. It says 2 sine squared x minus 3 sine x plus 2 equals 0. So what we're going to do is we're going to take this pi over 6 and substitute it for every x in this equation. Okay, so remember, let me remind you that this sine squared x is really written, because remember, mathematicians are lazy, it's really written as sine x squared. So the sine squared x is just a shorthand for sine x squared. So mathematicians wouldn't have to write these parentheses every time. So we got to remember that when we go plug it back in, because we're not squaring sine, we're going to be squaring x, okay? So, or whatever our sign of that value is. So let's go ahead and substitute 2, well, not substitute 2, but we're going to substitute pi over 6 for x. So 2 sine, instead of saying sine squared, we're going to say sine pi over 6, and then that is being squared, minus 3 sine of pi over 6 plus 2 is equal to 0. So as you can see, I just substituted for x and put that pi over 6. Okay, so now this is where you're going to have to evaluate, okay? So on this one, we're evaluating to see if it works. So you're going to need to go look on your unit circle and see where sine of pi over 6 is. So go look on your unit circle. So find pi over 6 and find sine. Well, what do you have? That looks like 1/2 to me. Okay, I'm going to highlight it so you can see it. 1/2. So that's what we're looking for. Okay, so go back over here. So we know that 2 times, well, we just found out that sine pi over 6 is 1/2, parentheses, squared, right? Minus 3 sine of, well, we've already found the sine of pi over 6 is 1/2 plus 2 equals 0. Okay, so now let's just do the math behind this. So we're going to square 1/2. Well, when we square 1/2, we get 1/4, right? Minus, I put this sign in here and that wasn't supposed to be there because we've already figured out the sign. So we have 3 times 1/2. When we get that, we get 3/2 plus 2 is equal to 0. So at this point, you could just plug this whole thing in your calculator. You could have plugged, if you made sure that all of your parentheses there, you could plug into calculator and see if it gives you 0. So you're really asking yourself, does this give me 0? Well, I'm just going to go ahead and do the math because I know 1/2 times 1/4. Well, I can change that to a 2, and this becomes a 1. So I now have 1/2 minus 3/2 plus, well, common denominator. I can make this 4/2, and they would all have the same denominator, right? So then I get 1 minus 3, which gives me a -2, plus a 4. Let's see, so we have, that's a -2 plus 4, that would give me a 2 equals 0. Well, is that true? Well, that would be 1 equals 0, so that does not work. So this would be no. This is not a solution. Okay, so pi over 6 is not a solution to this problem. I am going to skip number 2 because it's going to give you a no too, and but I will post this on my notes. I will have number 2 written down that you can go and look over that to see how we got that one. Maybe I should, no, I'll just put it on my notes, okay? So it doesn't end up working out either. So now let's look at number 3. So number 3, this is solving. So you can, it should probably have like a line right here saying this is different problems now. So now we're just solving. So we're not verifying. It doesn't say x equals something. We're trying to figure out what x does equal. So I have steps over here to help us. So it says solve the equation. You have to isolate the variable using inverse operations. So this is where this inverse comes in. So we're going to kind of treat this just like we do a regular equation if it didn't have a sign in it. You're going to try to isolate the x. So we're going to try to isolate this sign x. So we want to get everything else to the other side, okay? That's what we're going to do first. So the first thing we got to think about, PEMDAS backwards, right? So we need to add and subtract first. So if we do that, we can add over 1. So you get 2 sine x is equal to 1. Now, what do we need to do? You got to divide by 2 to both sides. So we get sine of x is equal to 1/2. So this is where your trig, the inverse trigs, come into play, because we need to figure out what the x is. We need to isolate this now. We can't just divide by sign. We've done problems like this before. You can't just go and divide by sign and call it a day. You actually have to multiply by the inverse of sign. Okay, so you're doing that to both sides. So this becomes inverse of sign over here. So this ends up canceling out. So then you're left with x is equal to the inverse sign of 1/2, which puts you into what you did last night. So we're trying to figure out, remember you are, for sine, you are restricted to quadrant 1 and 4. Well, sine is only positive in quadrant 1. So it really would be only in quadrant 1. Quadrant 4, it would be a negative 1/2 if it was in quadrant 4. So let's go look at our unit circle. And let's see where sine is 1/2. Well, sine is 1/2 right here. So it's 1/2 at pi over 6. So all it's asking for is it's saying, where is sine 1/2? Well, it's 1/2 at pi over 6. So that's our answer. Okay, what do you think? So we can verify that this is true by going and plugging this pi over 6 back into the original equation and seeing if it gives us 0. So we can always do that. Okay, let's look at number 4. Okay, number 4, remember you're trying to get tan squared x isolated first. So that's what we need to do first. So let's add over the 1. So that leaves us with 3 tan squared x is equal to 1. Now, we got to divide by that 3, get it to the other side. So we have tangent squared x is equal to 1/3. Okay, so here's the thing. On this one, we have a squared. So how do we get rid of a squared, something squared? Well, we've got to take the square root of both sides. So when we do that, we get only 1 tan. But what happens when we take the square root of something? We have a plus or minus the square root of 1/3. Okay, so if we go look at our unit circle, we don't have anything that says 1/3 on it, do we? Nope. But this is not pretty. We can't leave something written as a square root of a fraction. So we're going to have to split this up and say square root of 1 over the square root of 3. And now we can kind of do some more math here. Well, we can't have a square root in the denominator, so we're going to have to rationalize the denominator by multiplying by square root 3 to the top and to the bottom. So what do we get when we do that? Well, what's 1 times square root of 1 times square root of 3? Square root of 3 over, well, what's square root of 3 times square root of 3? Square root of 9, which is just 3. And that is on our unit circle. So remember, we're supposed to technically multiply both sides by the inverse tangent, because this cancels out, sorry, not the x, but the tan x and the inverse tan. And then we're left with x is equal to plus or minus, oh, forgot my tangent. X is equal to the inverse tangent of square root of 3 over 3. And then also x is equal to the inverse tangent of negative square root 3 over 3. Now, why do you think that it split them up? Well, because you have that plus or minus, so we've got to figure out both of them. So we've got to figure out where tangent is a positive square root 3 over 3 and where tangent is a negative square root 3 over 3. So remember, we're restricting tangents to quadrants 1 and quadrant 4. So let's go take a look at our unit circle. So where's tangent square root 3 over 3 if we're only restricting it to our first and fourth quadrant? Well, here it is at pi over 6. And then it's also here at, remember, we're not using these because it's got to be sequential. So it's got to go in sequential order. So that means you got to use these negative pi over 6. So we have a positive pi over 6. We have a negative pi over 6. So that's the answer to this equation. It's going to be x is equal to negative pi over 6 and pi over 6. So we were just evaluating where these tangents were on our unit circle, given our domain restrictions. Okay. Remember, you can, if I'm going too fast, you can always pause. You can always ask questions. Why don't you guys do that right now? You can pause the video, ask each other questions, help each other out. Make sure that you really kind of understand this, because these ones are actually the easiest ones when we're solving. We go to the back, they're not as easy. Okay? So pause if you need to. I'm going to go on. Okay, look at 5. What is different with 5 than what we've been doing? Notice on 3 and 4, they're all equal to what? To 0. Well, this is not. Number 5 is not. So maybe we need to get it to be. So if I want this to be 0, maybe I should move over the 2 cotangent of x. So that's going to look like, still going to have this cotangent of x times cosine squared of x. And now I'm just going to subtract that minus 2 cotangent of x and have it set equal to 0. Okay, so this kind of goes back to like the verifying identities and all that kind of stuff. So I'm hoping that you can see that we need to take out a GCF. Okay, because does anybody see the GCF that we need to take out? Because right now there's no way that we can solve this. So we're trying to get them down to, we're kind of trying to break it apart that we can set maybe like binomials equal to each other, maybe something like that. So do you notice that you have 2 cotangents? So we're going to go ahead and factor out that cotangent of x. So what does that mean we're left with? Well, we have a cosine squared of x minus 2, and that equals 0. So if we take the cotangent out of the second one, we're left with just a negative 2. Okay, so at this point, we can stop and we can set the cotangent x equal to 0, and then we can set this equal to 0. So we're just doing that because remember our this was called our zero product property that states if you had like x and then you had x squared minus 2 equals to 0, then you can say, oh, I'm going to set x equal to 0 and I'm going to set x minus 2 equal to 0 and then solve for both of those x's. So that same property applies when you're looking at these trig equations. Okay, so now let's start with the pink one. Let's go with cotangent of x. So I need to isolate that x. So that means I'm going to technically multiply this by cotangent, the inverse cotangent. Or another word you could say is arc cotangent. So that leaves us, these end up canceling. So we're left with x is equal to the inverse cotangent of 0. Well, if you go look at your unit circle, there is no cotangents. We have tangents, which I've written mine in green over here. We've got all these tangents, but we don't have cotangents. But we've done these before. This is kind of all coming back. We know that cotangent and tangent are reciprocals of each other, right? But we don't want to have 1 over cotangent because that doesn't get us really anywhere. But we could take the reciprocal of our 0. Well, what is the reciprocal of 0? Anybody remember? I spelled reciprocal wrong. I'll try that again. The reciprocal of 0. So it's going to look like 0 over 1. And if we flip that, that becomes 1 over 0. What does anybody know what that is? Undefined. Okay, so now we're looking for the inverse tangent of what's undefined. Well, let's go to our unit circle. Remember, tangent is restricted to quadrants 1 and quadrant 4. So we're only going to focus on 1 and 4. So where is something undefined? Well, it's undefined up here at pi over 2, but it's also undefined down here at negative pi over 2. So that's going to be our answer on this one. It's going to be x is equal to negative or plus or minus pi over 2. Okay, so we've just dealt with cotangent. We haven't even dealt with our other cosine squared x minus 2. Okay, so I'm going to bring this on down here. And I'm going to rewrite it so I can kind of talk you through this. Okay, so it's set equal to 0. So the first thing we need to do is we need to move that 2, that negative 2, over to the other side. So we get cosine squared x is equal to a positive 2. So far, so good. So we got 2 cosines, so we need to get rid of one of them. So let's square root, right? And so then we get cosine of x is equal to plus or minus the square root of 2. Okay, so now we've got to get that inverse cosine. So now I'm looking for when cosine is plus or minus square root 2. Is there anywhere that it's like that? I see square root 2 over 2, but I don't see square root of 2. Okay, so there's a reason for that. The reason is if you did square root 2 in your calculator, that's going to be approximately 1.4 something. I think it's like 1.41 something. Okay? Now, recall our unit circle. What is the biggest number that can be on our unit circle? What's our biggest number? It's going to be 1. So remember, the unit circle, right? The radius is going to be 1. That is the highest number that we can go to. So this does not even exist because it's bigger than 1. So because it's bigger than 1, we throw this whole thing out. It's not possible. It's not possible to find the inverse of square root 2 over 2. Square root 2, plus or minus square root 2, because it can't exist. There can't be a number less than 1, and there can't be a number less than negative 1 or greater than 1. So it's just thrown out. So this is our answer right here. This is our answer. We get x is equal to plus or minus pi over 2. So that's kind of tricky, kind of throws you. So if you see something like this and you're like, wait, this doesn't exist on my circle, on my unit circle, then you might want to question whether it's possible, okay? All right. Okay, number 6. Number 6 is hard. Number 6 is already equal to 0. Do you notice anything that this kind of looks similar to maybe something like a quadratic? Do you see that you have, might look like this if we didn't have our trig functions in it? Looks something like that. So there's 2 ways we could do this problem, because we've got to find out what these x's are, these sine x's. So we could do slide and divide. Factor this and do slide and divide. I don't think that you guys are the biggest fans of slide and divide. And if you like that better than what I'm about to show you, then I can show you that on Wednesday. But I think that you will like if we do the quadratic formula versus the slide and divide. So we need to think quadratic formula on these. And why can't we just factor this? Is because we have this 2 up front, which means that a is greater than 1, so that we would either have to slide that 2 over to that negative 1, or we're going to need to do quadratic formula. So just kind of appease me and let's do quadratic formula first. So remember quadratic formula, let's remind ourselves what it is. It's negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, quadratic formula. So now we've got to determine what are our a's, what's our a, what's our b, and what's our c. Okay, so what is our a? Or our a in this case, I'm going to change this, is going to be 2. 2 is our A. So we're going to plug A is going to be 2. Okay, so now let's look and see what B is. B is right here. It's going to be that -1, or this one. And we're going to plug that B into every place we see a B in our quadratic formula. So we get -1. And C is going to be this, -1. So let me just remind you, it looks like this. So A, so some trig equation, plus B, some trig equation, because this could be cosine, or it could be tangent, or it could be cotangent, and then plus C equals 0. So that's kind of where I'm getting those A, B, and C's from. So C, in our case, is going to be -1. So every time I see a C, I'm going to put there. Oh, I forgot one A. Okay, so let's just plug it in. So we get -1. So it's a negative times a -1. Okay, plus or minus square root of B squared. So that's got to be in parentheses. Minus 4 times A is 2 times C is -1. I'm going to move this down a little bit so I'm not squished. All over 2 times A, which is 2. Okay, let's do the math. So a negative times a negative is going to give you a positive. Plus or minus the square root of -1 squared is 1. And now we've got -4 times 2, which is -8, times another negative is going to be a +8 divided by 2. So now we get 1 plus or minus the square root of 9. Love it when it's a perfect square. Divided by, ooh, I did not multiply that right. Okay, so that is not 2. 2 times 2 is a 4, not 2. Okay, so 1 plus or minus square root of 9 over 4, which is going to equal 1 plus or minus 3 over 4. So remember at this point when we did quadratic formula last year and freshman year, you would get 1 plus 3 divided by 4, and then 1 minus 3 divided by 4. So right here, you have to split. Remember, you're splitting these. So the plus and minus. So 1 plus 3 is 4 over 4, which is 1. And then you get 1 minus 3, which is -2 over 4, which is -1/2. Okay, so we've got technically our x's. Does everybody see that? We're technically, or this is what we're looking for. So now you've got to bring it back to, well, we have these signs in here. Because if we would have factored this, we would have factored it, we would have set sine equal, we would have done the inverse of sine, we would have done all of that, just like we did in the other problems. So we kind of have to go back and add in our inverses. So we have to take this 1 and we have to say the inverse sine of 1. That's what we're looking for. And then we've got to do the same thing over here. So the inverse sine of -1/2. We're just trying to find out what they are. Okay, let's go find out what the inverse of sine is. So remember, sine's restricted to 1 and 4. So if we look over here, where do we see where sine, remember it's cosine and sine, is a 1? I see it right here. So that's occurring at 1/2. So let's go over here and we're saying that is not 1/2, but it's pi over 2. Okay, let's go find out where sine is -1/2. Remember, we're restricting it to 1 and 4. So -1/2 is right here. which means we're looking at negative pi over 6. And come back over here and say negative pi over 6. Okay, so those are your answers. So x, because it's x right here, so x is equal to negative pi over 6 and pi over 2. That's your answer. I know that was a lot, but if you look at it like the quadratic formula, it's not too bad. And hopefully it will work out nicely. Okay, let's look at number 7. Okay, we're going to do the same thing on here because look what it looks like. Looks like a quadratic, right? So we're going to have to do quadratic formula. How do you know it looks like a quadratic? You've got a squared. Uh-oh, there is 2 of these. Okay, so can we just go here straight away? Nope. No. This one is a little bit harder because we're going to have to use Pythagorean identities because these are not the same. Do you see that? Yuck, they're not the same. So we're going to have to apply our trig identities. So we have a trig identity for sine squared. Okay, so what is it? Everybody look. It's 1 minus cosine squared x. It's the same thing as sine squared x, right? So let's see what happens if we just substitute, instead of sine squared x, we plug in the Pythagorean identity, so P theorem for sine squared x. Okay, so technically, I don't know why I keep saying technically, we have to distribute that 2. So if we distribute that 2, we get 2 minus 2 cosine squared x plus 3 cosine x minus 3 equals 0. Okay, so we can do combine like terms here. Does anybody see where you can combine like terms? Well, we have a 2 and we have a negative 3. So it looks like, well, 2 minus 3 is going to be a negative 1. So we have negative 2 cosine squared x plus 3 cosine x. These are all the same, but now we're combining like terms, so we get a negative 1 is equal to 0. So again, remember, this is kind of like a cosine squared x plus b cosine x plus c equals 0. And now we can use the quadratic formula. This is when we want to use a quadratic formula now, okay? Okay, so remember we have our a, which is negative 2. We have our b, which is 3. And we have our c, which is negative 1. So we're going to plug that into the quadratic formula. I'm going to do it fast. So if you need to pause, please do so. So negative b, which is 3, plus or minus the square root of b squared minus 4 times a times c, all over 2 times a. Let me make sure all of my stuff is correct. Okay, it looks like it. So we get negative 3 plus or minus 9. Okay, so let's do this math here. We get a positive a times a negative, so I get a minus 8 all over negative 4. So we get negative 3 plus or minus the square root of 1 over negative 4. Well, what's the square root of 1? 1. Hopefully you said 1. So negative 3 plus or minus 1 over negative 4. So now you split. This is when we split. So we get a negative 3 plus 1 over negative 4. and a negative 3 minus 1 over negative 4. Okay, math. Here we go. So this is going to give us negative 3 plus 1 is going to give us a negative 2 over negative 4, which is going to give us a positive 1/2. So remember, you're going to change this to, because we're dealing with cosine, you're going to find the inverse cosine of 1/2, and you're going to figure out what does that equal. Okay, let's do the bottom one. When we split, negative 3 minus 1 is going to give you a negative 4 over negative 4, which gives you a positive 1. So now, change that back to the inverse cosine of 1. So now, go to your unit circle. Let's see where we have the cosine of 1/2. Remember, cosine is limited to quadrants 1 and 2. So we're looking for cosine. So I see cosine right here at, well, not 60, at pi over 3. So I'm going to say pi over 3. Well, I just wrote 6. Pi over 3. It's late. Okay. And now let's go find where cosine is 1. Cosine is 1 right here at 0. So that's going to be 0. Okay, so then that is, your answer is x is equal to 0 and pi over 3. Okay, so now I want you to go look at your homework. Let's see if I